Hello, today I'm going to take you into the field and we are going to compare of what I believe at this point in time is the only legal PMR446 radio with external magnetic mount antenna. It's designed for mobile use or a base station, and yes, it have external antenna, but it comply with the regulatory requirements because the antenna is non-removable. It is fixed, so it comply with the norm and it have a half watt of output power. To make this test as fair as possible, we are going to compare it against the commercial grade PMR446 radio from the Motorola, the XT660D, but we are going to use this on analog mode on exactly the same channel. This is also a PMR446 radio with a fixed antenna. Let's make some basic assumption. If we plug those two radios on my bench, if I go to the kitchen, grab a metal pan and stick the magnetic antenna on top, I'm pretty sure that those two radios are going to perform exactly the same. Maybe the Midland is going to be a little bit worse because of loss on that coaxial cable. Everything should change 180 degrees as soon as we grab our antenna with a ground plane and stick it outside of window. In my case, I'm in my lab, so if we put it outside of window, then this radio should always outperform that, both on receive and on the transmit. You might get feeling that you are going to get exactly the same benefit from just grabbing this radio and moving it next to your window, but that's not the only gain. The handheld radios are designed to be operated from hand, and if you are grabbing this radio like this, you've got 15 or 30 centimeters from your face, you are transmitting, then the part of the RF energy is going to be hitting you, your body, and it's going to be basically lost and converted into heat. This is exactly why I've got a speaker microphone, because that allows me to extend my arm and to not be in a direct reach of the RF energy that is being transmitted. I can pull it into the air and I can keep a vertical polarization. That's the main benefit of having external speaker microphone. But here we do not have that problem. We can have this antenna more than one or couple wavelength. We can clear all the obstacles around and we should get a much better radiating pattern. But just imagine that we go inside car, we've got a metal frame around us that is acting as a Faraday cage, and you might make a very good point that UHF is not attenuated as much as a VHF because the wavelength allow some of the RF energy to pass through a window, but it will always reflecting something. It will always affect your radiating pattern because it have to go through your windows and there are going to be some blind spots. Some RF energy is going to be lost. So speaking from handheld radio inside your car with the antenna close to your face is always bad idea. If we stick that antenna on top of your car rooftop, we are going to get absolutely beautiful ground plane. We've got absolutely no obstacles around more than one wavelength of distance, and it should work absolutely beautiful. Absolutely beautiful. This is my prediction. How the test is going to be performed, I grab those two radio into vehicle, the antenna goes on top, wire through a sunroof, and we are going to do a couple range checks. At the base station we are going to be receiving audio, so you will be able to hear subjective way how it sounds and whether there is a difference. but also I choose as a receiving radio Motorola, which got a RSSI indicator. So you are going to get a numeric value that you can calculate and you can work on to make a compare how they are performing. Absolutely last word, because 100% sure someone is going to ask that question. This is not a range check. I'm not interested in the distance. I'm interested in comparing of transmit performance of this radio with the antenna on rooftop and that radio inside of a vehicle, because that's going to tell us whether it is worth of purchasing and whether it's making a difference that is significant enough that is justifying all that hassle of having a separated mobile radio. So let's go into the field. 1, 2, 3, 4, 5. Position number 1. 1, 2, 3, 4, 5. Testing from Midland rooftop antenna. 1, 2, 3, 4, 5. Position number 1. 1, 2, 3, 4, 5. Testing from Midland rooftop antenna. 1, 2, 3, 4, 5. Motorola internal antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Motorola internal antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 2 from car rooftop antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 2 from car rooftop antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 2 from handheld antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 2 from handheld antenna. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 3. Testing from Midland GB1 car rooftop antenna. 1, 2, 3, 4, 5. Radio check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 3. Testing from Midland GB1 car rooftop antenna. 1, 2, 3, 4, 5. Radio check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Radio check. Testing from handheld Motorola. 1, 2, 3, 4, 5. Position number 3. Handheld Motorola. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Radio check. Testing from handheld Motorola. 1, 2, 3, 4, 5. Position number 3. Handheld Motorola. 1, 2, 3, 4, 5. Position number 4. Car rooftop antenna. Midland GB1. 1, 2, 3, 4, 5. Position number 4. 1, 2, 3, 4, 5. Position number 4. Car rooftop antenna. Midland GB1. 1, 2, 3, 4, 5. Position number 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 4. Handheld Motorola. 1, 2, 3, 4, 5. Radio check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position number 4. Handheld Motorola. 1, 2, 3, 4, 5. Radio check. 1, 2, 3, 4, 5. Position number 5 on the move. Rooftop antenna. 1, 2, 3, 4, 5. Position move. Rooftop antenna. 1, 2, 3, 4, 5. Position number 5 on the move. Handheld radio. 1, 2, 3, 4, 5. Radio check. 1, 2, 3, 4, 5. Position number 5 on the move. Handheld radio. 1, 2, 3, 4, 5. Radio check. I just finished reviewing the test footage directly from my camera, and the Midland GB1 performed exactly as beautiful as I expected. On the Motorola, you can clearly hear the noise floor went up while I was speaking, when on the Midland it was a total silence. I also encourage you to take a look at the RSSI value, because I saw at least a 10 dBm difference between those two radios. So we've got a absolutely beautiful transmit on that radio. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.